Hello everyone. Today, myself, Nicholas, Kit, and Jim are going to teach and explain the average rate of change and the instantaneous rate of change. Before that, let's learn about limit and what limit generally is. Limit is when the function converges to a single number, especially when the function is 1 over 2 to the power of n. According to the graph of 1 over x, we can see that as the value increases along the x-axis, the graph moves towards 0, but never exactly touches 0. Therefore, the limit of 1 over 2 to the power of x is 0. Limit does not work when the function does not converge to a single number, like y equals x, because the function extends from both positive and negative, and does not tend to stop before a number. In limit, there are two main formulas we used in class, and that is the average rate of change formula and the instantaneous rate of change formula. Average rate of change is the change in position over time, and the formula used is f bracket a plus h minus f bracket a divided by h. The average rate of change requires 2 points, and for the graph, we need to draw a straight line that cuts through 2 points. The line is known as the secant line, and we can use the formula to find the slope of the secant line. For the average rate of change formula, we would first need 2 points from an equation, and the equation for this example is fx equals to 1.4x minus 4. The 2 points we chose are x equals 4 and x equals 8. We can then use the formula to find the average rate of change for those 2 points. In order to find h, we must then take the second point minus the first point. For this question, x equals 2 is the first point and x equals 4 is the second point. Let's sub the points into the equation of the average rate of change with the function. After the average rate of change, it is time to introduce the instantaneous rate of change. If the average rate of change is the slope between the 2 points, the instantaneous rate of change should then be the slope of 1 point. The reason for it is due to the word instant, because instant means exactly at one particular point, and average can be multiple points, and we then find the average. Instantaneous rate of change uses the same formula. The difference between the formula is the h in the formula. The formula for average rate of change is that h cannot be 0, and for the instantaneous rate of change, h is always equal to 0. We will now use the same equation, 1.4x minus 4. We will include the rate of change when x is at 8. Now, use the equation to find the slope when x is at 3. Due to the math principle, we cannot divide a value with 0 or 0 divided by 0. Therefore, we cancel the h in that equation, and the instantaneous rate of change is 3. That is the difference between instantaneous rate of change and the average rate of change. But we have a little more. Let's go on this journey briefly. First principle derivatives is part of the instantaneous rate of change because they are tangents to the graph. For the first principle derivative, we just need to add limit as h approaches to 0 to the equation. There are two types of equations. One when the general point whereby x equals x, and a specific point of x equals a. The first question we did above for instantaneous rate of change can be used for a specific point in the first derivative. That is due to the theory of limit. When something approaches a value, it does not mean it equals to the value. We can show an example for the general point. Same equation, x squared as h approaches 0, we can say that it equals to 0 because it is the same when 2.9999 infinite numbers of 9 equals to 3 because the value is so close to 3.
Created using Powtoon.